Two decisions shape everything about how your session hosts perform and how easy they are to maintain, how you size the virtual machine, and how you build and version the image it boots from. In this lesson we cover sizing by workload class, choosing the right Windows edition, the golden image workflow, versioning through Azure Compute Gallery, automating builds with Azure Image Builder, and the trusted launch and disk type decisions that round out the build. There's no single right VM size for AVD. Light task workers doing data entry tolerate high session density on modest hardware. Medium knowledge workers running the full Office suite and video calls need a meaningfully lower sessions per vCPU ratio to stay responsive. Heavy power users, engineers, and designers often need close to dedicated compute per user, and sometimes a GPU-enabled SKU. And don't forget disk IOPS, an undersized disk can bottleneck a host with plenty of spare compute, especially during a profile load or a morning boot storm. The practical sizing workflow starts with Microsoft's published workload class guidance as a baseline, translates that into a target number of sessions per host for a pooled pool, and then validates that target against a real pilot group actually doing their day-to-day work before committing to the SKU for the entire fleet. Skipping the pilot step is how organizations end up resizing hundreds of hosts 6 months after go-live. Windows 11 Enterprise Multi-Session is licensed and engineered specifically so multiple users can run independent, concurrent sessions on one virtual machine. That's what makes pooled compute cost-efficient, and it's the default OS choice for pooled host pools. Personal host pools, where each VM belongs to exactly one user, typically use a standard single-session edition instead, since there's no sharing to support. Either edition draws on the same family of eligible Microsoft 365 or Windows per-user licenses. A golden image is built once, tested once, and rolled out consistently rather than configured host by host. Build the image with your OS, applications, agents, and baseline configuration in place. Generalize it with sysprep to strip machine-specific identifiers. Capture the result as a new version in an Azure Compute Gallery image definition. Then deploy new session hosts from that specific version, and repeat the whole cycle on a regular refresh cadence. Azure Compute Gallery is the versioning and distribution layer for your golden images. Every build becomes a new image version under an image definition. You can replicate a version to every region where you deploy session hosts, and your deployment automation references a specific version by ID, which means you can stage a new version to a validation host pool first, then roll it out deliberately, and roll back to a known good version if something goes wrong. Azure Image Builder automates the whole build generalize capture sequence. You define a template with a base image, a list of customization steps like scripts and Windows Update, and a distribution target, and AIB provisions a temporary build VM, applies the customizations, captures the image, and publishes it directly as a new Azure Compute Gallery version. Because the template is just an ARM or bicep resource, the entire image process becomes repeatable and source-controlled instead of a manual process different engineers do slightly differently. Trusted Launch combines secure boot and a virtual TPM to protect the boot chain and the kernel against rootkits, bootkits, and malicious code injection, and it enables Credential Guard on top. Azure Virtual Desktop supports provisioning Trusted Launch virtual machines from custom images stored in Azure Compute Gallery, and given there's no meaningful downside for typical AVD workloads, treat it as a default on baseline rather than an optional extra. An ephemeral OS disk is created on the session host's own local storage instead of remote managed disk storage, which speeds up reimaging and removes managed disk cost. Because non-persistent pooled hosts are meant to be stateless and disposable anyway, losing the disk on deallocation isn't a problem. A fresh golden image is exactly what you want on the next boot. Personal host pools, where the OS disk needs to persist with the VM, stay on managed disks. Sizing and image strategy together determine whether your session hosts are fast and maintainable or a constant source of tickets. A pilot-validated VM size paired with a properly versioned golden image is the baseline every production AVD environment should start from, and both of these decisions feed directly into the deployment automation we build in the next lesson.